Okay. Another opportunity to display our fantastic skills with partial integration. All right. So what do you think we do? We make this guy the dv, right, and make him u as before.
We just make a chart.
Huh?
We just build the chart since we don't know what n is. Just compare it.
Well, what I'm going to get here is an expression that involves the next one down. Then that'll be a recursion expression, and I can build on top of what I have here for t, and then we'll see what it is.
Okay.
I think we'll see it. Let's do this one and you'll see where it goes. Okay, so what's this one going to be? uv is t to the n e to the minus st over s with a minus sign in front, again from 0 to infinity, minus the integral e to the minus st n t to the n minus 1 dt, right? True enough? First, my son says, "True, Dad?" What the hell does that mean? You heard that?
Yeah.
What's that mean? Is that true? Or that is true? Is it not?
Yeah.
Yeah. True that? You have to kind of say it like
You
it.
ever
True
heard that?
I know.
Who are your sons
I
black?
remember people at my house who don't talk like that.
They're probably all white.
Everybody,
They
yeah.
are.
That's real life.
That's exactly the problem.
Yeah, I think
The
that's
black
a
ones
lot.
don't talk.
Yeah,
Yeah,
the
they
white
don't.
kids are
That's
more
a white
ironic
thing.
than the others.
They think it's cool to act like they're not.
Yeah.
Plus, here's another L'Hopital problem. This one is the nth power, but this one still kills it.
So that goes to 0.
Up and 0, it really kills it at the bottom. So no contribution from that. There should have been another minus sign here. So once again, it's plus. And so now I get n integral 0 to infinity t to the n minus 1 e to the minus st dt, which is n times Laplace transform of t to the n minus 1. That's the recursion I'm looking for. So if n is 2, for example, we should have this. The Laplace transform of t squared should be 2 times the Laplace transform of t to the 1, which was
1 over s squared.
yeah. And you see what's now going to happen?
And factorial.
They're going to build up with factorials as we go. But wait. But wait. There's a 1 over s that we lost here somewhere. Where'd it go? Oh, it went here. I remember. I integrated. Remember, I integrated dv, and there was a 1 over s here.
Yeah, yes.
Sorry for the disruption. That's not a 5. Oh, that's a s. I'll tell you. That's an s.
It's like the only letter that ever used.
I hope you guys, some people write 7s or 1s like this, so you can get that confused with 7s. A 9 you can get confused with Q, right? And a Z you can get confused with 2. So usually the style is to put the bar through the 7, the bar through the Q, and the bar through the Z.
Yeah. I usually do that. Put the bar through the 2. I usually put bar through the 2.
No, that's a 2.
I just make sure I make
Here, I did this. I was, okay, which one of those is a 2, which one's a Z?
It makes a difference. Whichever one you put the bar through is the Z.
A 1 looked more like a Z, like a 2 to it. I'm sorry. And it's also a good idea to write 4s like that.
Yeah.
I
Okay.
get confused with 9s.
So much, that's kind of first grade stuff. But it does make a difference. People.
It's not just first grade stuff. Computer programmers have to learn that stuff.
Yeah.
Engineering graphics have to learn that stuff. Drafting.
Okay. So we have a recursion formula, we think that t to the n is n over s L t to the n minus 1. We can track that all the way back down. And what do we get? This one then would be n minus 1 over another factor of s times the Laplace transform of t to the n minus 2, and we run that all the way back to Earth here, and I think we get n factorial over s to the n plus 1. Okay? All right, that's good. Okay, how about this one? This one will actually be pretty easy. E to the alpha t. Okay? And what's this integral?
E to the alpha minus S times T over alpha minus S. Why is it minus?
I was going to turn one of these around. Sorry.
Oh, S minus alpha, yes.
Okay, I'll just turn it around in the integral right now. So we have e to the minus s minus alpha t. That looks more like what we've been doing. So now we have minus 1 over s minus alpha e to the minus s minus alpha t 0 to infinity. So at infinity, this kills everything. At 0, it's 1, but we're subtracting the lower limit, so minus minus makes it, which is the transform of e to the alpha t. Okay? So we'll,